Thank you. So, yeah, my name is Sasha Romijn. I am a professional. I've done over a decade of being a professional software engineer mostly. I do a lot of Python, Django, lots of other stuff. Used to work at RipeNC a long time ago. A lot of my work is open source, which is more fun. I get to share things other people contribute from the community. And I'm not quite a network operator, so like different from the average here. I do have my own ASN in the DF set. And other than that, I also do all sorts of community organizing. I'm on the core team of a documentation community, Write the Docs. And I'll start briefly, I think this is known to many of you, but about what is the Internet Routing Registry, basically. For the relevance for IRR Explorer, basically, it's you can register routes that you or other people intend to announce. There's kind of has a lot of fuzzy edges. There's registration data also in some of them more than others. There's all kinds of other things. Some people put poems in there, some of the databases. But there's there's a number of automated tools for building filters based on IRR data, like BGP-Q4. And there are a number of different registries. There's about a dozen that are well-known and popular in different sizes, different policies. Some of them are free. Some of them are very restrictive on their data. Some are more liberal. And a lot of them mirror each other's data. And IRR is pretty old, so there's a lot of legacy in both the data and the code. There are some strange things in there. Some of the code is old, unmaintained, and especially the last part is something I've been working on a lot. And like was just said, the original version of IRR Explorer was built in 2015, mostly by Yap, but lots of other people were involved as well, lots of community contributions. And this is what the old one looked like. It's much prettier now. And the goal is basically to give people insight into the IRR records, the BGP data, and RPKI for a prefix ASN or AS set. The goal being that it would, to give it insights for yourself, but also for customers. So I say if you do IRR filtering, your customers don't understand why their routes won't make it through your filters. You can send them to IRR Explorer and they get a nice overview that is more accessible than sending them to various whois records, various databases where they should be creating route. This is like a nice quick overview that makes it easier to help yourself or help other people set up IRR correctly. But also as mentioned, there was a lot of room for improvement in user experience, reporting, maintainability, correctness. And also in the meantime, since 2015, I worked on the Internet Routing Registry daemon version 4, which is a rewrite of the legacy IRD and released 2 years ago. Years are hard. And so I built this project originally for NTT, and this is basically the server that answers IRR queries, that answers whois queries. It's now in use for NTT.com and Erin and LACNIC and DC. Some other people are looking into it. And it also handles authoritative object changes for some of these. But importantly, it also has a big overlap with things that IRR Explorer used to do on its own. So the original IRR Explorer would run its own mirrors of all the different registries, would collect its own data, parse RPSL records. But actually, all of that is in IRD as well, and the new version, this is implemented very well. There's also completeness, like complex elements of set resolving that old IRR Explorer just ignored. And so IRR Explorer v2 is a complete rewrite by me in Python and React.js, and it builds upon all the work that I put in IRD. There's a very nice new API in there that lets you query RPSL data in nice JSON also, so you don't have to parse all the individual RPSL fields. You get all the, so this is a very practical way to access IRR data. And there's just a lot of improvements in the reporting, in the user experience, maintainability also, because there's other ideas of how to develop this further, and also it's more complete in a number of cases. All this work was funded by RIPE-NC Community Projects Fund for Stichting NLNOG, who then hired me to actually build it. How does it work? Like I said, for a very large part, this builds upon my work for IRD4, which mirrors a number of registries, basically whichever you want to configure. Those are all the common registries that you've known, like RIPE, ARIN, EntityCom. They get mirrored into a local SQL database, and then IRD also does RPKI imports and validation. So it takes RPKI data, translates that into sort of fake route objects, but also validates all the other route objects, whether or not they are RPKI valid according to RPKI origin validation. And then that's all exposed on the GraphQL API. GraphQL is a query language which returns JSON. Then IRR Explorer itself gets data from IRR stats to figure out which IRR is this address space registered with. BGP.tools gives info on what is seen in the DFZ and also how many people see this, which origins are seen. That all goes into a database. A data collector aggregates everything and also figures out what should we actually look for in which registries based on the user query. That's enriched with reporting, goes into an API that is rendered in a React.js frontend. All the green parts are Python, and the other part is React. So this is a new tool. It's already live on irrexplorer.nlnog.net. And here's an example report for an ASN with all the prefixes. This is the most extensive part of it. I'm not going to name the AS, but someone in here is managing this, but it's not too bad. You can see, for example, on the top, there's a prefix 9120834, which is registered, which is RIPE-NC address space. In BGP, it's AS8283. There's a ROA for 8283, max length 24. There's a RIPE route object for 8283. So this is all fine. Like, this is all consistent. There's nothing unusual. Everything adds up. You can see some of the blue ones where there is a ROA for origin 8283, max length 24, but there's no BGP announcement that we can see. There's also no route object, so IRR Explorer highlights that. This isn't bad necessarily, it's not an operational impact, but this is like, I don't actually know why these people are doing this. I've seen other people do this, so maybe there's a good reason we should update this report, but it's highlighted as in, this seems odd. And then also you can see one retro in there, 185.52225, which is in BGP with origin 8283. There's a ROA for 8283, but there's no route object at all. There's an overlapping /22, which is fine. So if this is your network, there's no rush to fix this. But this is probably an error. I say probably because IRR Explorer tries to detect things that seem off, so especially in terms of whether things are red or blue or green. It's sort of a best effort on highlighting things that you might want to look at. There are people who do unusual things that make sense in their situation that are not always detected by IRR Explorer, but it helps for a lot of cases. Another thing it does is find other prefixes that overlap with prefixes that are associated with your AS. So for example, in the top part, you can see there's one prefix in a PNIC address space with also a route object in the PNIC database. There are a number of less specifics there. They're probably not really relevant in this case. Old IRR Explorer would just put this all in one big table. But in some cases, these are sort of adjacent address space that are in some cases also very relevant to you. Another example, this is froot. And so froot has two prefixes, a /23 and a /24. It's not RPKI signed. For the /23, there's one BGP origin, one RDB route object. They are consistent. There's no record in the ARIN IRR, though, which is why it's highlighted. There's also no RPKI ROA. And also, in some cases, you would not see a RPKI entry on the same line, because RPKI, you can do max length, so there could be a less specific ROA with a max length that makes this valid or invalid, and IR Explorer detects all of these. But also, you can see that for /24, there are other route objects in RDB. There are other origins, entity.com as well, which I don't know why people created them. There was no, you can pretty freely create them. But with IR Explorer, you can also dig into them and find out what these objects are, how you query for them. Also nice for less experienced users who don't really relate what they can query in Whois to IR Explorer. So you can dig into these objects and figure out where do they come from, who is managing them. Another nice feature that's new is you can query all the data as JSON. So basically you can get the exact data that was used to render this table. This is basically just the API call. The API call isn't really specifically documented or guaranteed to stay, but you can use it if you want. So this is everything you see in that table. So there's an IR route, status is not found because there's no RPKI data. There's all the warnings, there's generally how good or bad this entry is, and things like that. This example is RIS. And I use them because they do bad things on purpose. And you can see, for example, first row here, there's a prefix that is originated from 55303. There's actually a matching route object in RDB, but it's a PNIC space, and the PNIC IR says the correct origin is 12654. So that's why this is highlighted. Probably actually in this case, I think it's the PNIC route object that is old and left over, and maybe it was temporarily used by RIS. And you can basically most kinds of errors appear here. Also, I think you can see some of the ASNs have a check mark or a cross behind them, which means that that object is RPKI valid or invalid according to the ROA data that we have. So there's announcements in here without any route objects. There's conflicting route objects. There's one where there's a different BGP origin, different route object, and different RPKI. And these are all detected. I also like this one. This is new features also. We support prefixes that are announced from multiple origin ASs. So this is the worst one I found, I think, with about a dozen different origin ASs. And the route objects do actually all match. So this is valid, but highlighted because multiple different origins are unusual. I think this is Anycast being used from different origin ASNs, which is not common, but people do it. Also, AS sets are included in IR Explorer. So if you query for ASNs, you can see which AS sets your object is included in, but also the other way around, a full expansion in depth of AS sets. So for example, AS open peering peers has these direct members, but you can also explore further and see, for example, that at 3 levels deep, AS Apple is included through the path AS open peering peers, AS RTN, AS Apple, which then has members, and this goes all the way down until at some point we stop expanding because your browser will run out of memory. And you can also see interesting things. I still want to add more reporting for this. For example, here at AS open peering peers directly refers to ASnet, but there's 3 of them in 3 different databases in entity.com, right, and a PNIC, and they are all different. Which is sort of a challenge, also something I've encountered in IRD with. AS set expansion is AS set names that we refer to are not actually unique, and sometimes they're wildly different. These are, as far as I could find, also owned by 3 completely different organizations. So 3 completely independent people have chosen to create the same one. Which one did AS open peering peers mean to refer is, I don't know. Yeah, and you find other unusual stuff. If you query 0/3, there's a route. There's some unusual route objects and things in BGP that you run into. Like I said before, usually you can't actually query this. There are some limits on how big you can query for. I did actually try, like, what if I query like almost all the IPv6 address space and my browser died at a few gigabytes of RAM? So there are some limits. If you need to do these kind of things, then we should talk, because I'm sure we can build some kind of reporting tool around that. And so that's IRR Explorer version 2. All the code is on GitHub under a fairly open license. So if you're interested in new things or think the reporting should be tuned, there's probably cases where the reporting is slightly off, then do make a GitHub issue, a pull request. And thank you.
Right, well, thank you for improving this software so much, Sasha. It is really helpful to the operator community. As somebody who believe has enabled on AS8283, I would like to say that these weird things are not so weird. They are for anti-DDoS. So
I thought so.
I think we're okay there. Any other questions for Sasha? Martijn.
Yes. So thank you for the IRR Explorer. I love the tooling, but I have a problem. If I enter my AS set, it breaks down. And this is because one of our downstream customers has claimed the same AS set name as a certain Chinese incumbent in the IRR operated databases, whereas the Chinese incumbent is doing things in RADB. So because we are not really trusting whatever is going on in RADB or other third-party databases, for us it would be very relevant to only see on the IRR-operated databases, right? The clean routing registries. Is there any plan to kind of give you filtering capabilities so that you can only expand from, let's say, a subset of all the IRR databases?
Not yet, but we could do it. Like, it's not difficult. So, yeah,
that would be very wonderful.
You're talking about AS set expansion, right?
Yes.
Yeah, yeah.
Yes, so in my AS set, there is a different AS set, and in APNIC or in RIPE, it means something different than the one in RADB, which is huge.
Yeah, the more fundamental solution is that we stop using things as primary keys, which are actually not unique at all. And I don't know how that happened, but it was a very poor choice.
Unstoppable force versus immovable object.